Brought to you by the Astro Youth Taos Chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM art students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast. I'm Shaylee Marable.
I'm Taylor Strite.
I'm Hattie Rose.
So today's very special episode we're excited to share with you guys.
We'd like to welcome Dr. Julia Bluebird. If you could go ahead and tell us a little bit about yourself.
Julia Bluebird, Alachepi, Pine Ridge, South Dakota, Hamata, Ayash, Socorro, New Mexico, Elwati. I'm Julia. I'm from Pine Ridge, South Dakota. That's where I'm from. And I currently live in Socorro, New Mexico. And I am a radio astronomer and also an engineer. And I once worked in building spacecraft to go into space, and now I just actually study space. And so I do both of those things.
That sounds super cool. What different things have you built that contributed to space exploration? Or what have you built in the space field?
So when I first entered NASA, I worked in research and development, and we were designing a communication system to go on the surface of the moon. And so it'd be like have broadband network on the surface of the moon that all the vehicles and lunar rovers and everything could talk through. And I did that for a couple of years. And then after that, I moved into being in charge of the design and development for the communication system for the Orion spacecraft. And that is a craft that is designed to bring several astronauts to the moon and also at the time to Mars. And it's similar to the capsule that they use in the Apollo missions. And so I was able to work on that as well.
Could you elaborate a bit on what exactly is radio astronomy?
So astronomy itself is a pretty big field. And so we use different telescopes to study different things in space. And so if you take, for example, a telescope like the Hubble Space Telescope that works at frequencies and part of the electromagnetic spectrum that your eyes see. And so there's many different types of things that we can study with the entire electromagnetic spectrum. And so it goes all the way from X-rays to ultraviolet light, visible light, infrared, and then you also have radio waves. And so I study galaxies, and simply put, galaxies are made of stars and gas. And so if you want to look at the stars and take images of the stars, you can use wavelengths that are similar to what your eyes see. But if you want to study something like the gas, which is much further out from the center, you can only see those with something that can observe in radio waves. And so that's what I do.
And you said that you worked at NASA. How did you start working at NASA?
So when I was a little kid, I grew up out in the middle of nowhere in South Dakota. And we didn't really have anything out there, but we had the sky. And so during the day, I would lay on my back and look at all the clouds and make shapes. I'd pretend all the clouds were the shapes of animals and things like that. And then at night, I would look up at the stars And I always just wanted to go up there. And so it was always my dream to work at NASA. And it was just something very far-fetched, and I didn't even know of an engineer or scientist until I went to college. But when I was 4 years old, I had a bunch of older brothers and sisters, and so we would play all the time, but I realized that I needed to go be by myself sometimes. And so my dad had this big recliner in the corner, and it was next to a shelf full of books. And I would sit there by myself, and no one could see me, and I could hear everyone saying, "Where's Julia? Where's Julia?" And I was just a little kid, and there was a book in there, a little thin book, and it was called The Universe, and it had all these beautiful pictures in it, and it had pictures of galaxies. And I remember taking that book out and just sitting there and looking through that, and that was the first time that I was dreamt of space and becoming obsessed with it. And so I grew up wanting to be at NASA. And so that's kind of how all of that started. It started when I was very, very young.
Do you have any advice for somebody who would want to work in a similar field, like going into NASA, for example?
I would say have big dreams and work really hard and don't give up. When I graduated from undergrad with an electrical engineering degree, my whole goal was to work at NASA, and I didn't get a job there. And I remember being so heartbroken and just felt like I blew it. But I ended up being an engineer. I built terrestrial communication systems, which means communication systems that are on the ground. And I had these amazing jobs. You know, those big towers on the side of the roads or on mountaintops where you see antennas. I would get to climb those and build antenna communication systems there. And it was just an amazing experience to have those jobs. And after several years of doing that, then I had the experience to be able to enter NASA as a radio frequency engineer. And so my dream ended up happening, and it didn't happen the way I thought it would. It didn't happen instantaneously. And it was much better for me to enter NASA years later, knowing exactly what I wanted to do there. So it all worked out. And so I would just say, keep dreaming and keep working, and your dreams can come true.
That's so amazing. Thank you for sharing. I want to ask, you brought up a bit of where you come from, and so how does all the space work that you've done and everything you've studied, how does that tie back to where you're from and the earth that we live in for you?
I think well, in so many ways, but so indigenous people have always had a deep connection to the sky, and Lakota people have that as well. And so we have our own constellations, and we have our own ways that the stars and tie into our way of being. And so it's all related. And so it's amazing to be from people that were so tied to the night sky, and to be able to go to school and be trained in like Western science and all of that, have that balance out the way that we're like natural physicists and sky watchers anyway. I think that it feels amazing to be able to do that, actually.
Thank you so much.
What has been your favorite project that you worked on throughout your years of being both an engineer and working with astrophysics and radio astronomy?
Wow, that's hard. That's really a hard one to answer. I think every step of the way, everything I've always worked on just feels like such a dream to be able to do that, to be able to watch Orion launch into space was pretty spectacular. I cried like a baby the whole time. And so that was really a triumph. to witness that. And I also think of what I do on an everyday basis. I make these amazing images of galaxies that are billions of light years away. And every job I've ever had and everything I've ever done, I always think, I can't believe I get paid to do this. And so I think that's probably my favorite part of that. But just being able to look at a galaxy that no one's ever probably seen before and try to figure it out. Galaxies are very complicated structures, and it's a very complicated story to try to tell the autobiography of the biography of a galaxy. And um, so I think that's one of my favorite things as well.
Do you have any favorite galaxies or anything that surprises you the most that you've discovered through your journey?
I discovered a galaxy when I was in school, and I was in New York City. It was during quarantine, and so we were all stuck in our apartments. And I discovered this galaxy, and it was really a miracle that I discovered it. But it's a tiny galaxy, and in my research and the observational limits that we have, we look at galaxies that are very far away, billions of light years away. And so because of that, we tend to see we're only able to see bigger galaxies. And so this particular galaxy, it's called a dwarf galaxy. It's tiny, and it has a lot of neutral hydrogen gas around it, which is what I observe with the radio telescopes. And so it was a miracle that I could find it. It's a very rare thing to find, to be able to make it the kind of image I made of this galaxy, and it's far away. And so I think that's been my favorite galaxy so far.
Can you explain a little bit more what neutral hydrogen is?
So hydrogen is the most common element in the universe. Most of the known universe consists of hydrogen. And so outside of galaxies, hydrogen is in an ionized state, which is just a different state of hydrogen. And then within galaxies, hydrogen is in a neutral state, and it's called neutral hydrogen. And basically, that is the raw fuel for star formation. And so if you have a galaxy, you have the central part of the galaxy that is stars. Much further out, you have this hydrogen gas, and that gets pulled in from the surrounding environment. And so this hydrogen gas is basically the fuel for the stars. And so I study how much of this hydrogen gas is there, and I try to understand how it comes into the galaxy from something called the cosmic web, or the large scale structure of the universe.
Can you explain how you can tell what kind of hydrogen, like which is which?
Yeah, that's a great question. They have signatures in the spectrum that we can identify. And so there's a very specific line. It's called the hydrogen line, and it emits energy at that specific frequency. And so as you go further out, that frequency gets redshifted, so the frequency changes. And so depending on where that particular line falls, that's how we know how far away it is, for example. And so that's one reason that we know it's a signature of neutral hydrogen, is that you can see it at a very specific place.
Going back towards where you're from, you said you're from South Dakota, right?
Yes.
What made you want to come to New Mexico specifically? Was there anything specific, or was it just a random place that you chose?
So I love New Mexico. I've been here a few times before, but New Mexico has a very large radio telescope. It's actually called the Very Large Array, the VLA, and it's outside of Socorro, New Mexico. And so this is an array of dishes. There are 27 of them, and they're about 25 meters across. And they're in the shape of a Y, and the Y acts as like one giant antenna dish. And so it's one of the most, it is the most productive ground-based telescope in the history of astronomy. And a lot of people don't even know that that is in the backyard here in New Mexico. And so that is the reason why I was able to move here. And I used that instrument. I got my dissertation using that instrument.
Well, that's really cool. I find it interesting how we always have so much that's so close to us and we never really even think about it.
Mhm.
Because I didn't know about the Very Large Array until maybe about a year or two ago. So I find that really interesting.
You know, New Mexico has a lot of amazing telescopes. There's another set of telescopes at Apache Point, and there's a survey that they did with that telescope there, and it it surveyed millions of galaxies. And this survey allows us to actually be able to image the cosmic web, or the large scale structure of the universe, which is pretty amazing. So that was done on an instrument just down the road from here in New Mexico as well. So there's a lot of amazing astronomy happening here, and there's a lot of opportunities for people who are interested in astronomy here in New Mexico.
So you've talked about how much different things that you've researched and worked on. What is something that in the future you would really be interested in going into?
Oh, that's a great question. You mean as far as the research?
Yeah,
Or
researching or just working on a project, just something that interests you that you haven't really branched out to yet.
there's so many things as far as the research. There's so much that the more I've learned, the more we all realize how much we don't know. And so there's endless things to learn and study. So, and I feel the same way about astrophysics as I do with electrical engineering. Is you can never know it all. And I think that is one thing that I love about it, because you'll never get bored. You'll never feel like it's just ordinary or something. It's just always, you're constantly learning and learning new amazing things. And so as far as my field is, there's so many things I want to study. I could never know it all.
Thank you. That's an incredible response. Also, just wondering, could you elaborate real quick on what exactly is a dissertation?
So a dissertation is what I write to get my PhD. And so it's a body of work that you work on for several years. And it's basically your body of research. And then at the end of your schooling, you put your dissertation together, and then you stand in front of a panel of experts and you have to defend it. And so you get grilled on it, basically. And if you pass that, then you get to graduate with a PhD.
What specifically was your dissertation on?
So the title of my dissertation is Neutral Hydrogen Gas in Galaxies Across 5 billion years in time. So across 5 billion years in time is 1/3 the age of the universe. So it was called Neutral Hydrogen Gas in Galaxies with respect to large scale structure across 1/3 the age of the universe.
Thank you. That sounds super interesting. Is there a way for us to potentially read your dissertation, see your research?
Yeah, you can. It's on it's called the archive. It's where the astrophysics research is kept. And it's like a NASA archive. And I can give you a link to it, and you can just click on it and download it.
Oh, thank you.
So I was going to ask before, you briefly mentioned something about a cosmic web. What exactly is a cosmic web, and how would you, as a scientist, define or identify it?
So the cosmic web, we call it the large scale structure of the universe. And if you could zoom out and see the universe there's a structure to it, and it kind of looks like a web. It has more parts of it that are more dense and parts of it that are less dense, and it kind of can resemble bubbles in a way. And though the web is made out of galaxies, and so it's individual galaxies, and so some of them are closer together, and some galaxies are kind of off on their own and more isolated. And so if you could zoom out and pinpoint every galaxy, the way that looks, the structure is, it looks like a web. And so that's why we also call it, it's kind of a slang, we call it the cosmic web. And so I study how galaxies, where they lie within the cosmic web and how they get their gas from it.
So, is there a lot of like big gaps throughout the web? Like, is it only just dense galaxies, or is it also like dark matter, or gas, or like gaps of space?
There's definitely very dense parts of it, and there are parts of it that are less dense. We sometimes call those voids. And so you can have very large spaces where you might only have a few galaxies in them. So there's definitely both extremes.
How or where does your research focus on when it comes to the cosmic web? Like, are you looking at how it forms, or how it evolves, or something else possibly?
So the survey that I work on, we take this telescope, which is here outside of Sapporo, and we take it and point it at a certain area of the sky. And that area of the sky is about the size of a full moon, or if you put your thumb up on the sky, it's about the width of your thumb. And we just stare at that area of the sky for 1,000 hours, which is a very long time in telescope time. And in looking at that patch of the sky, we're just blindly, in an untargeted way, trying to see how much neutral hydrogen gas we can detect. And when we detect it in and around a galaxy, we can study, what I study specifically is when galaxies rotate, they have a vector that they rotate on. So if you can think of a galaxy as a flat pancake and it's rotating like this, it's rotating around an axis, kind of like those old toys, the tops that would spin. Like the part that spins, that's similar to the vector that I study in galaxies. And so I study how that vector is aligned to filaments in the cosmic web. Because small galaxies, it's basically, I'm studying how they spin. So small galaxies will spin in parallel to the cosmic web filaments, and big galaxies will spin perpendicular to it. And so I study very specifically, that's one of the things that I study. And the reason for that is the way small galaxies form by accreting this neutral hydrogen gas from the cosmic web along the filaments. And so they start spinning in parallel with the filament. Bigger galaxies, small galaxies merge together to form big galaxies. And so these galaxies end up merging along the cosmic web filament in a perpendicular way. And so it has to do with how they grow. And so we have another part of astronomy is people do these really elaborate simulations, and they're pretty detailed. And when they do these simulations, they can make predictions. And so when they make predictions, we can target our observations to say, here's what the theory and the simulations predict. Is that really true if we can observe it with our data? And so that's one of the things that I do. So the simulations predicted that smaller galaxies would spin in a certain way in relation to the cosmic web, and bigger galaxies would spin perpendicular. And I am starting to find that in my research. So it's pretty exciting.
So what exactly is like the tipping point between a large and small galaxy, and how do you determine that?
That's a very good question. And so we usually define galaxies by their mass, and we define it by their stellar mass. And so that's basically the mass of all of the stellar component, all the stars added together. That usually is how you classify whether a galaxy is small or a galaxy is large. And so there's like a cutoff in their stellar mass.
So is our galaxy, would that be considered a large or small galaxy?
Our galaxy is considered a larger galaxy. There's galaxies that are much larger than ours, but ours is a fairly large galaxy. And if you look a bit in the sky, we have our nearest large companion is the Andromeda galaxy. That's a galaxy that's 2 million light years away, and you can see it with your eyes if you go outside and look for it. It's pretty spectacular. It's one of my favorite things about living in New Mexico because I can sit on my deck at night and I can see with my own eyes a galaxy, which just kind of blows my mind. If you lived in the southern hemisphere, we have 2 smaller galaxies that you can see in the night sky, but only if you lived in the southern hemisphere. So those are small galaxies. You can see those with the naked eye. But Andromeda is the only large galaxy that we can see. You can see that from your backyard here. I would recommend you all try to do that.
What are the names of the 2 other smaller galaxies?
One is a small Magellanic Cloud, and it's SMC for short. And the companion is the Large Magellanic Cloud, and it's LMC for short. And those are both dwarf galaxies, the Milky Way local group.
Thank you for talking to us and letting us ask you questions. Is there anything else that you want to add or say to any of our listeners?
I always like to encourage people to go outside and look up. And every time I talk to students, I give them homework. And your homework is to do that at least once a week. And especially for those of you that live in New Mexico, it's such an amazing thing. You can see so many stars. It's just beautiful black velvety sky that you can see. Just go outside and start looking up and see what you can find. So I just want to encourage everyone to do that.
Thank you so much just for everything and the insight. We really appreciate it.
Thanks.
Yes,
Thanks so much.
thank you so much.
Thank you.
It's fun to talk to you all. Thank you.